Um,
What
I
letter
don't
do we
know.
usually use for slope? Do you remember?
X?
Well, yes,
No.
sometimes we do use A, yes. That would definitely be a sometimes case.
Oh, I said X.
Oh, X? I heard A.
Yeah.
Sorry, not X.
Well, I don't know.
Like, do you remember what slope does, like what it tells you about a line? We usually think of it
No.
as a fraction,
Um,
something over something.
oh, well, it's rise over run.
There you go. Were you thinking too
Okay,
hard, Leah?
maybe.
Yeah, I think so. Yeah, so slope we know as rise over run. That's a really easy way to explain slope. Rise over run. We also can explain it as the change in y over the change in x. And I was telling you that there's different math symbols that we use. The little triangle symbol represents change. So the change in y over the change in x. So that little triangle means change in math. All right, one more way to think about slope. I gave you some words. Peter, do you remember the formula for slope?
Um, oh, I was just gonna say that it's the m and the y equals mx plus b,
Oh,
but I don't.
yes. Yeah, so I'm going to come down here. He said it's the m in the line y equals mx plus b. So I'll write that down here since you gave me that information. So slope is the m variable. Does anybody remember the formula for slope? It's a fraction.
y2 minus y1 over x2 minus x1.
Nice, Jack. And when you're talking about the words, I have change in y over change in x. Finding the change in something is finding the difference. So when you see that word, the change, what is the difference? How does one value change to the next? So y2 minus y1, x2 minus x1. And remember, it's rise. So that's why the variable is the y variables on the top, because it's rise over run. So the y's rise, the x values run left and right. So there are 4 cases for slope, which kind of seems weird to call it a case. But there are really 4 different ways to describe a line, and the slopes help us describe what type of line we have. So I don't know who that is. Can anybody describe a case for slope? So think
Like
about,
whenever it's 0, then that's like straight, and then
okay, so
when
before
it's
you say straight, Jack, what else, what other word could you use for straight?
horizontal,
Okay, yes. So if we have a slope of 0, it is a horizontal line.
and if it's undefined, then it's vertical.
Nice. All right, so there are 2 cases. So a case of slope would be like, what is the number telling us? Well, if slope is 0, we have a horizontal line. If the slope is undefined, and I'm just going to abbreviate here, writing UND, that's when we would have a vertical line. Make sure you spell vertical correctly. Remember, undefined slopes happen when I have some number divided by 0. So if I had 5 divided by 0, that's when my slope would be undefined.
And then when it's negative, then it slants down.
So negative means it would have to be less than 0. And we say that that would fall or decrease from left to right.
And then if it's positive, then it rises or increases.
Nice, Jack. And remember, lines move from left to right, just like you read words on a book from left to right. So if it's less than 0, it falls or decreases from left to right. And then last case, if it's greater than 0, it would rise, or we would say it increases from left to right. Any questions? So there are 4 ways that you can graph a line, which means those 4 ways to graph a line correspond with the 4 cases of slope. That's just a little review of those cases. So by looking at the slope, you should be able to say the line increases, decreases, is it horizontal or is it vertical? Peter gave us the slope-intercept form. Peter, I'm going to come back to you. You said the M represents the slope, therefore the B represents?
The y-intercept.
Yeah, the y-intercept. Remember, you begin with B, you move with slope, hence the M and the B in the equation. So we're going to look at the first example here. And it says during the year 2006, so this is a company, Research in Motion, their net profits, that means what they're worth, or the money that they're bringing in for the year, was $631.6 million. And then in 2007, the profits were $1,293.9 million. Or we could have flipped that to billion as well and said $1.2 billion. But in a math problem, we try and keep our labels consistent. So if we use millions with the first number, we keep it as a million form in the second. So these values are in millions. So it's not just $631, it's millions of dollars. It says to write a linear model giving the net sales in terms of the year. So if we're writing a linear model, that's the same thing as writing an equation of a line. We're calling it a model because it's off of a word problem, but we want to write an equation of a line. So if we're writing an equation of a line, we need to find a couple things. Jeremy, what's one thing that you need if you're writing an equation of a line?
The slope.
Yeah, how would you find the slope in this problem? What do we have to do to figure out slope? What would we need? Do you know, Jeremy?
The rise over run.
Yeah, we need the rise over run. So if you take the information that's given and try and think of it as being an X value versus a Y value, we're given the year 2006. And in 2006, it says the profit of this company is $631.6 million. So if I think of that as a set of a point, a XY value being paired together, I can then help us find the slope of the line. Now, remember, when you have a year, we never use a year in an equation. So I'm going to take this year of 2006 and really call it the year 0. So this would be the initial year of the data or information that's given to us. And in the year 0, or the initial year, the company made $631.6 million. I'm not putting the million in the problem. We'll use that later on in the answer. 2007 is only 1 year later. Could have given us 2010, and it would have been 4 years later, but it's only 1 year later. And 1 year later, we're at 93.9 million. So Jeremy said we need to calculate the slope, which is rise over run, or change in y over change in x. So see if you can find the slope, change in y over change in x. So I would take the y values and find the difference of them. And then the x values, well, that's really easy because it's just 1 year. If it was more than 1 year, I would have those values. So if it was 4 years, then I'd have to divide by 4. So we'd have to divide by the number of years in order to find the slope. Jeremy, do you have the slope for this problem?
Just 1 second.
Yep, that's fine. She's doing in she's music class.
$662.3 million.
You said 0.3, right?
Yeah.
Yeah, okay. So that's our slope, 662.3. And then what's the y-intercept?
631.6
Yeah, why?
because it's at the x-coordinate of 0.
Excellent. The y-intercept is where the line crosses the y-axis. If it's on the y-axis, it means our x value must be 0. So this first ordered pair is our y-intercept. Any initial value that's given to you in an application problem is your y-intercept. It's the starting amount. It's where the graph crosses the y-axis. So writing an equation of a line or a linear model is fairly straightforward if we can calculate the slope and understand that the original year represents the y-intercept. So now the second part of the question says use this equation to estimate the net sales in 2010. So we want to use this equation. We want to figure out the net sales or the profit in 2010. That would be our y value. Oops. So do we plug in 2010 into our equation? Grant, what do you think? Would we put 2010 in our equation, Grant?
No, we would put 4.
Yeah, 4. It's 4 years later from the initial value. So if you plug this in your calculator, we should then have an estimate of what the net sales would be worth if they continue to rise at the same rate. And we're just going to have to assume that that's going to occur. It might not, but it probably will be close. Don't forget to label your answer. Grant, do you have a calculator with you that you could plug this number in?
Yeah, I'm plugging in now.
Okay, thank you.
I got 3,280, but it'd be 3,280,000,000, right? Point.
Yeah. Was there anything after the 80?
Oh, 0.8.
Okay, yeah, let's get that in there too. There we go. So you can write it like this and write the word million after it, if I can spell. Or you could say 3.28 and then you could write billion as well. Either one of those are acceptable. So you could keep it in millions because the original information was given in millions, or you could write it as 3.28 billion. Any questions? So we created a linear model using the information that was given, trying to take the year, think of it as an ordered pair. The initial amount that was given is our y-intercept. And that'll always be the case. The initial amount they give you is the y-intercept. Questions? So we have 3 other little pieces of information down below, and then we're going to do 2 more equations, and then we're done. So general form of an equation, we talked about slope-intercept form. Every equation that we work with, or every function that we work with, has 2 different ways to write it. So you have your graphical form, that would be slope-intercept, or the graphing form that we talked about in chapter P was that AHK form, where it was like A and then in parentheses x minus h squared plus k. That's called the standard form, or the graphing form. But every equation also has a general form. And a general form is when it's equal to 0. So standard form we can easily graph from, but general form is usually used because we want to solve for something. Let me write this in a different color. I got a lot of stuff going on here. So we have a general form of a polynomial. We have a general form of a rational equation. When the equations are set equal to 0, it's in general form. When they're in the graphing form, we can easily pull numbers out of the equation to graph. General form is used to find x-intercepts, y-intercepts, or to solve for x or y. It's usually what we use general form for. The other 2 words down here would be the way a vertical line versus a horizontal line would be written. So if you have a vertical line, we said the slope was undefined. Does anybody remember what the equation of a vertical line would look like?
Y equals 0.
You were close, Peter.
X
But-
equals something.
Yeah, so a horizontal line is actually in y equals form, and I'm just going to say y equals a, and we'll just say a is any number. And the little word that I like to kind of think about, which is really a made-up word, but if you think about a horizontal line has a slope of 0, and it has to be in y equals form. The other way to think about it is the horizon. So the horizon has the sun falling into it. The sun would be our slope of 0. Our y equals line is horizontal. A vertical line is of the form x equals, and we could say a. So I use the word hoi, horizontal, slope of 0, y equals form. For a vertical line, and I guess it's not a word, acronym, I use the VUX, vertical undefined slope in x equals form. So again, the V represents the type of line, the U represents the slope, the X represents the form the line should be written in. It's an x equals form when it's a vertical line. Anything that'll help you remember that. Those are just two things that commonly get flipped. So thinking about a vertical line, it's crossing through the x-axis. For a line to cross through the x-axis at a value, it has to go vertically through the x-axis. Any questions? Okay, so 2 more things to talk about, and then we're done. The last thing we're going to talk about lines. So we know there's 4 cases of slope. We know we can calculate an equation for a line using y equals mx plus b by calculating the slope. And then I can have parallel lines and perpendicular lines. And that's pretty much all we can do with a line. So parallel versus perpendicular. So Gianna, if we have a parallel line, do you remember what happens with the slopes of parallel lines?
Isn't the slope the same, but you just change the y-intercept?
Yeah, very good. So she said the slopes are the same. They will have different y-intercepts. Nice job. And they have to have different y-intercepts, otherwise they'd be the same line. But the slopes are the same for parallel lines. That's the key fact of parallel lines. We have to have the same slope, different y-intercepts. So then perpendicular lines would be our other option. If they're not parallel, they could be perpendicular, or maybe they're not any of those options, but we can have perpendicular lines. Jenny, do you remember what happens with the slope of perpendicular lines?
They have to be the opposite reciprocal.
Nice job. Both words there too. What's opposite mean, Jenny?
One has to be positive, one has to be negative.
Excellent. So a 1/2 and a -2. Opposites, one positive, one negative. Reciprocals, one would be the flip of the other. So our last example that we're going to look at wants us to be able to write an equation of a line that passes through a point, and the point is 2, -1. And then they're telling us that we want to find this new equation or second equation that's parallel to this line 2x minus 3y equals 5. So I have a current line. I want to find a second line that would be parallel with this current line. And it has to pass through the point 2, -1. Any idea as to what we need to do to start this off?
You have to get it into y equals form.
Yeah, nice, Darby. So we're going to have to take the given equation and get y by itself so that we know what the slope is. So I'm going to do that work on the side. Take the x over. She said get it in y equals form. So if I divide by -3, just be careful. we would have a positive 2/3 and then minus 5/3. Of course, I couldn't give you a nice one. Has to have fractions. So get it into y equals form. Darby, what do you use then from this equation once it's in y equals form? How do we use that equation to help us find another line that would be parallel to it?
Wouldn't you just plug in the 0.2 minus or 2 comma negative 1 to figure out what the parallel is, or would you just use the slope?
So we are going to use the slope of this line. We're going to kind of do both. So here's the slope of this line. Parallel means it has to have the same exact slope. So my parallel slope is going to have to be the same. And then we are going to plug in 2, negative 1, but we're going to plug it in so that we can find a different y-intercept. So I need to get a new y-intercept. That means in this equation, mx plus b, I need to find a different b value. So if I need to find the b, Darby was correct. We're going to plug in that x and y, but we're going to plug it into the y equals mx plus b form because I want a different y-intercept. I'm not going to have the same one as negative 5/3, and that negative 5/3 doesn't have any bearing or effect on our new y-intercept. So see if you can insert that point in, and we can use slope-intercept form to help us do this. We could also use point slope form if you prefer to do it that way as well. Either way, we need to find the b value. Keep it in fraction form. Don't convert this to a decimal. So once it's a fraction, it stays as a fraction. When you're multiplying 2/3 times 2, that gives us 4/3. And then we need to take 4/3 to the other side by subtracting it. Get yourself a common denominator. So I have negative 4/3 minus 1, or minus negative 3/3. So now I should have an equation of a line that is parallel to our existing or our original line. And that equation would say y equals 2/3 x plus b. Well, I just found the b value to be negative 7/3. So here is my parallel line. I can tell it's parallel because it has the same slope and it has a different y-intercept. And we found that y-intercept by using the ordered pair 2, negative 1. Questions? So if we go to do the perpendicular line, notice the equation is exactly the same. So we don't have to get this equation in y equals mx plus b form because we already solved for y equals mx plus b. It's the same equation or the same line that we were given in part A. So Joe, what would the slope be if we're trying to create a perpendicular line?
It would be negative 3/2.
Yeah. We're going to use that same point. So we're finding an equation of a line that passes through the point 2, negative 1. Our slope is the only thing that's changing. So again, y equals mx plus b. Now we're using that slope of negative 3/2. So we can have a perpendicular line. So for the y value, I'm still using negative 1. For the x value, we're still using positive 2. This one works out a little nicer. So multiply that fraction with the 2, take it to the other side, and see if you can find a b value. Does anybody have the b value, the y-intercept?
I got 2.
It should be negative 4.
Okay, so I heard a 2 and a negative 4. Let's look here. So if we multiply these together, let's see. I know that this makes a negative 6 when I divide it by 2. I get a -3. And when I add 3, so be careful of that negative sign, we end up with a +2. So I think that was Peter who gave us the +2 value. So y equals -3 halves x and then +2. Does anyone have questions? So the homework tonight, there are 10 problems in the book that talk about finding slope, writing an equation of a line, parallel perpendicular lines. Hopefully it's fairly straightforward. I'm done. No other notes to go over. You have about 7 minutes. So have an awesome weekend. It's going to be a little chillier tonight. Nice campfire weather. And I'll see you all on Monday. And in 2 weeks, 2.5 weeks, hopefully I see half of you in the classroom too. So have a great weekend.
Thank you, you too.
Thank you.
Thank
Miss
you. Have a
Kane.
good weekend.
See you later.